In this video, we're going to learn the 7-step process to complete the one sample z-test for proportion. Step 1 is assumptions. There are 2 assumptions you need to check for: random, and that's just like we did before, the data must be collected randomly, and normal distribution. Now, to prove normality with proportions, we do a little bit different. We have to figure out what n times p hat equals, and that value must be greater than 5, and n times q hat, and that value must be greater than 5. Recall from earlier, p hat stands for the sample proportion of success, and q hat stands for the sample proportion of failure. The next thing we need to talk about is how do we figure out the critical value. And critical value is all based on the alpha. So once you figure out what alpha you have, either stated in the problem or not, you need to figure out which type of test you have: left tail, right tail, or two-tail test. If it's a left tail test, you must find alpha in order to find your critical value. If it's a right tail test, you take 1 minus alpha, and your critical value will be a positive number. If it's a two-tail test, you take alpha divided by 2, and you get 2 at critical values, plus and minus. For example, let's say we wanted to find the critical value for a left tail test with an alpha of 0.05. So since it's a left tail test, I just need to find 0.05 within this table. It's halfway in between these two values. So I'm going to, of course, round up, and I'm going to state my critical value as negative 1.65. Next, let's suppose we're given a right tail test with an alpha of 0.10. So to find our value, we take 1 minus alpha, and then we find that value, 0.90, on the table. So here it is on our z table, which results in a critical value of 1.28. Last but not least, let's find a critical value for a two-tail test that has an alpha of 0.05. So you take alpha divided by 2, which will give us 0.025, and we look inside the z table and find the value 0.025, and then identify the corresponding z critical value. So our critical value here would therefore be negative 1.96. As mentioned in the beginning of the video, there's a 7-step process for performing a z-test for proportion. Step 1, you check your assumptions. We already listed the 2 assumptions. The 2 assumptions were that the data must be collected randomly and the data must come from a normal distribution. Next step, you will state the null and alternative hypotheses. So the null hypothesis would be the population proportion is equal to some value, and our alternative hypothesis will be the population proportion is not equal to, greater than, or less than that stated value in the null hypothesis, all based on the context of the problem. For step 3, you need to find the critical value, which is the process that we just went through. Remember to state your alpha and what type of tail test it is. Okay, in step 4, the test, we're going to find the test value, which is going to be calculated using our test formula. Step 5, you're going to find the graph. And there are 3 things that you need to make sure you label on the graph. 1, the critical values. 2, the test value. And 3, either you reject or fail to reject the null hypothesis. P-values can be found either with your calculator or by using the table of values. But since everybody's required to have a graphing calculator for this course, I'm just going to teach you how to do it using your calculator. In step 7, we need to write your conclusion sentence. Remember that you must include the sentence in context to the problem. In step 4, we find the test value. So how do we find the test value? We'll use the following formula. The formula for test value is z is equal to p hat, which is our sample proportion, minus p, which represents our population's proportion, divided by the square root of a population's proportion times q, which is found by taking 1 minus p, or sometimes this is referred to as a population proportion of failure, divided by our sample size. All right, let's do our first example. People who are trying to avoid trans fat. So take a moment, pause the video, and read this example before we begin working through it. Step 1 is identify the assumptions to make sure that we can perform the z-test for proportion. So recall that our first assumption is randomization. So this time we know that our data was selected randomly. It was stated in the problem. The assumption is normally distributed. Now we find this by testing n times p hat. So in this problem, our sample size is 200. Our p hat is 128 divided by 200. So n times p hat, we take 200 times 128. Notice I didn't simplify this fraction because the denominator and the 200 always cancel each other out. And I get 128 is greater than 5. Now I need to test in q hat. So q hat is what's left over, the ones that did not believe in avoiding trans fat. So we end up with n times q hat is equal to 72, which is also greater than 5. So since n p hat is greater than 5 and n q hat is greater than 5, we can assume that our data comes from normally distributed data set. For step 2, we're going to identify our hypotheses, starting with our null hypothesis. So looking at the problem, what is the claim or what is the thing that we're focusing on about the population? We're focusing on that the proportion of people who believe are trying to avoid trans fat is 60%, so we write that proportion as a decimal. So our null hypothesis is p is equal to 0.06. Look at the problem to see if there's any context clues about if it should be a one-tail or two-tail test, but we notice there's not any context clues, so our alternative hypothesis is p is not equal to 0.6. Now we're ready for step 3, which is to find the critical value. So we identify first alpha, which is 0.05. And then we look at our alternative hypothesis to figure out which type of test it is. So we have alpha is equal to 0.05, and this is a two-tailed test. So the process of finding our critical value for a two-tailed test is take alpha divided by 2, and we get 0.025. We look inside our z table, and we find 0.25, which we did earlier. So that gives us a z critical value of negative 1.96. Forget, since this is a two-tailed test, we have to include our plus or minus to that value that we get from the z table. Okay, for step 4, we're going to find our test value using the formula z. Test value is equal to p hat minus p divided by the square root of p times q divided by n. So let's look. P hat, if I change that to decimal, it would be 0.64. P we identify from our null hypothesis, which is 0.60. Q is 1 minus p, so that will give us 0.40. And n is our sample size of 200. Substitute those values into our formula. And I do need to see this work when you substitute the values into the formula. Make sure you show that on your paper. And we end up with a z test value of 1.1547. Step 5, we're going to graph. So we're going to draw our normal curve. And then we're going to first plot our z critical values and shade each tail. Next, we're going to plot our z test value. Now remember, the top of the curve and the maximum point of the curve is at 0. So our test value should be about 1.15 here. Since the test value falls in the unshaded region, we will fail to reject the null hypothesis. So make sure you label that on the table. Step 6, we're going to find our p-value. I'm going to use the calculator to find our p-value by hitting the stat button, cursor over to test tables, and then cursor down until I see the one proportion z-test. Once you push enter, you will see the following information pop up on your calculator screen. And then what you need to do is just plug in the information given in the problem. P0 stands for the population proportion, which is 0.60, or you can find that in your null hypothesis. X is the number of successes in your sample. N is your sample size. And then you look at your alternative hypothesis to figure out which one of the following to highlight. In this case, are not equal to. And then we push calculate. When you do this on your calculator, you will see one row that says P equals. That is your P value. So our P value here will be 0.24821. Next, I'll take this P value and compare it to the alpha given. And I notice that 0.24 is greater than 0.05. And so that's going to also help me in my conclusion to this problem. Conclusion must be written in complete sentences, and it must include information about p-value, about if you reject or fail to reject the null hypothesis, and how you came to that decision. So here's a good example of a conclusion that you can write. Since p-value is greater than alpha, p-value equals 0.2482, which is greater than 0.025, which equals alpha, we fail to reject the null hypothesis. There is not enough statistically significant evidence to reject the claim that 60% of people are trying to avoid trans fat in their diet. So make sure, notice how I referred to this in context of the problem, talking about not only p-value, but if I fail to reject or reject the null hypothesis, and what results I get from that, if there's evidence or not enough evidence. All of that must be stated in your conclusion. Okay, now it's time for you to try one. So pause the video, read this problem, do all 7 steps, and see how you do. When you are finished, come back, and then and only then push play, and let's check your work. All right, step number 1, you need to find the assumptions. Recall that there are 2 assumptions for the z-test for proportion. First one is random. So I look at the problem and I notice that it does talk about sample, but it doesn't specify randomization of the sample. So I must assume that they did a good sampling technique and they did a random sample was used to collect the data. Because it also doesn't mention anything about it being a volunteer sampling or something like that that's not random. Next, I need to check and see if I have a normal distribution by doing n times p hat. So that'd be 80 times 55 over 80, which simplifies down to 55, which, yay, it's greater than 5. Then I do n times q hat, which is 80 times 25 over 80, which becomes 25 is greater than 5. So both of these pass the test. Therefore, since n hat is greater than 0 and n hat is greater than 5 and p hat is greater than 5, we can assume the population is normally distributed. Now we're ready for step 2, which is to state our hypothesis. Our null hypothesis would be that the population proportion is equal to 0.77. Next, we need to find our alternative hypothesis, so we look in context of the problem, and the key word I see here is that at least. So P will need to be less than 0.77. So there are our step 2, our null hypothesis and our alternative hypothesis. Next, step 3, we need to find our critical values. So we need to identify alpha, which is at 0.01. And looking at an alternative hypothesis, we can see that this is definitely a left-tailed test. So I just look at alpha, go to my z table, find alpha of find a value of 0.01, which is ever is closest to it, and I give me a z critical value of negative 2.33. So my z critical value is negative 2.33. Now that I have my critical value, my next step is to find my test value. To find our test value, we use our formula. Z is equal to p hat minus p divided by p times q, or square root of p times q divided by n. Substituting in the values I know, you can either use the fractions or you can convert these to decimals. I'm going to use fractions this time. And my p is from my null hypothesis, 0.77. And then 1 minus 0.77 gives me my q, which is 0.23, divided by n, which is 80. Plug that into my calculator, and I get a z-test value of negative 1.75. Our 5th step is to sketch the graph of the normal curve. So we do a quick normal curve distribution On that, we need to label our left tail and our z-value of negative 2.33 and shade that left tail. Then plot our z-value at negative 1.75. Again, the z-value is not in the shaded region. So since our test value is not in the shaded region, we will also fail to reject the null hypothesis. Then we're going to use our calculator to find our p-value. And we get a p-value equal to 0.03976. Then we compare that to our alpha value, and we draw a conclusion. Since the p-value is greater than alpha, our p-value is equal to 0.0397, which is greater than 0.01, which is our alpha. We fail to reject the null hypothesis. There is not enough statistically significant evidence to reject the claim that at least 77% of the population opposes replacing the $1 bill with the $1 coin. Okay, now let's look at our last example for this video. So again, I highly encourage you to pause the video, work this problem out, and then only after you finish all 7 steps, push play and check your work. All right, let's see how you did. Step 1 is our assumptions. 2 assumptions that we need to test. First, we need to see if we have a random sampling. It did specify that a sample of 200 lawyers from a certain city was shown to have this information, so we assume the sample was collected from a random sampling. Next, we need to prove normality, and that's by taking n times p hat, which is equal to 63, which is greater than 5, and then finding out what n times q hat is, which is equal to 137, which is also greater than 5. So since those two answers are greater than 5, we can assume that the data is normally distributed. Step 2 is hypothesis. So our null hypothesis would be that p is equal to 0.25. And our alternative hypothesis would look for a context word. We see the word that the claim more than 25% of lawyers. So p is greater than 0.25. Step 3, we're going to figure out our critical value. So I need to write down alpha, which is 0.05, and which type of test this is. This is a right tail test. And when you have a right tail test, to find the value on your z table, you take 1 minus alpha, which will give us 0.95. So I'm looking for 0.95 on the inside the z table, which is in between these two values, and we always round up. So I'm going to use a z critical value of 1.65. Step 4, find our test value by using our formula. Z is equal to p hat minus p divided by the square root of p times q divided by n. So p hat will be 63 over 200 minus 0.25 divided by the square root of 0.25 times 1 minus 0.25 or 0.75 divided by 200. Type that into my calculator and I end up with a test value of 2.12. So that is my z value. Then I'm going to draw our norm curve graph, plotting in our z critical value first, which is at 1.65. That's my critical value. And then shade in that tail. Since this is a right tail test, the right end needs to be shaded in. Next, I'm going to plot my test value at 2.12. My test value falls in the shaded region. I can conclude that I need to reject the null hypothesis. All right. Step 6, find our p-value through our calculator. This part of my p-value is going to be equal to 0.01688. Compare that p-value to alpha and write our conclusion sentences. Since p-value is less than alpha, p-value is equal to 0.01688, which is less than 0.05, which equals alpha. We reject the null hypothesis. There is enough evidence to support the attorney's claim that more than 25% of the lawyers use some form of advertisement. Okay, I hope you now know how to do a one sample Z test for proportion, and please now do your assignment.